with the project you are doing now, your assignment. You are working with 2-cylinder, am I correct?
Yes, sir.
Because tomorrow is the day we are going to text the code, am I correct?
Yes, sir.
And I said we are using iWare, right?
Yes,
so
sir.
iWare is already here. And we have 3 groups, right?
Yes.
And each group program will be transferred here, and 2-cylinder are meant to work. Cylinder has a magnetic sensor at the back, at the home position. So when it's traveling, to get to the home position, this picks the signal. So literally, we know this cylinder either is at home position or this cylinder is a pneumatic cylinder. It has no magnet inside it. Okay, but in the front here, we put one sensor. So when it makes forward stroke, we picks it. We knows where it is, right? And when it's coming back, we don't know when it gets to the back. Okay, so we don't care about that. We're only interested in now. Those guys, they are the actuator, solenoid valve actuator with solenoid coil. Everything we discussed yesterday, have you? Yes, sir. Now, this is double acting cylinder. It's been connected already. It connects port 1 and port what? 2. And air distribution. The air has come in to give air to the inlet. The solenoid valve has inlet and what? Outlet. So 1 inlet, 2 outlet. 1 inlet, 2 outlet. This solenoid valve is controlling what? This. We can see the outlet from this solenoid valve comes here. So if you are working with this guy now, this is the cylinder, this is the actuator. Second cylinder actuator, am I correct? Yes, so we have other grippers and other things that I don't want to bug you with for now. Now, this is pressure gauge. What do I call this?
Pressure gauge.
Pressure gauge. Now, the pressure that will come in, like I said yesterday, air is the working substance of pneumatic system. The same way we have pneumatic system, we have the same thing like this in hydraulic system. Now, 24 volts, positive and what? Negative. That means there's 2 wires, have you?
Yes, sir.
Now, the way it works in the industry, let me give you a clear demonstration. Let everyone here put 2 of your hands up. Out. 2. I only need 4. Only 4. Yes, 1, 2, 3, 4. Okay. Now, this hand is 0. Put it down. This hand, 0 volt. This hand, 0 volt. This hand, 0 volt. All those hands, they are positive volt. You see, those hands that are 0 volt, I've joined this hand to this. I've joined this to this. I've joined this to this. They have common what?
Common 0 volt.
Common 0. Now, they are common 0. In my power supply, I've attached 0 to this. So I only need to put positive here to what? Positive here, positive here. So here, you will not see the second leg because I have joined them together as common what? Common 0. So you only see 1 signal. Does that make sense?
Yes, sir.
Okay, we see it now. Now, this is the power to the system. Inside here, I've installed the power supply that step down from 220 volt to what? To 24 volts. Now, this section, black and white, I've made them the power source. It means this is negative, this is what? Positive. That is the color coding in engineering. Positive are red, negative are what? Black. And they are the one I call common 0. Common 0. It means from here. So it means the guy is going to do solid work. I've made life easy. I've done a brief sketch of this. And the way I position them, I position them here. What did I call this one? Minus V0. This one called plus V24. That means this one, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Minus what? 1, 2, 3, 4, 5, 6, 7. Plus what? That means this one, they are the power source. With respect to what I have here. Are we together?
Yes, sir.
Now, see this section? This section? They are the sensors. I have sensor here. I call this one SS2. I have one sensor here. The first sensor, I call it sensor 1, sensor 2. So if I want to find out now, where is sensor 2? From here, sensor 2, I come here, I know it's somewhere here, but I've done the legend, sensor 2, terminal 39, SS2, 39, where is 39? 39. So where is 39 here? 39. Can just point to 39. Simple. I expect everybody to get it. That's that. So now I know that this guy, sensor 2, where sensor 2, if this man come here to activate that sensor, I know this man will give me output. However, to make life easy, I've connected the sensors again to the input of the PLC, because sensors, they give input to PLC, right? I've connected the sensor to the input of the PLC. Now, if you look at this PLC now, if you look at, there are 2 lights that comes on. Just 2 lights, right? Power and run. Am I correct? Yes. Power and run. Okay. Now, if any of the sensor get activated, let's see. Can you see this? Terminal what? Terminal 2. That sensor has been wired to terminal what? Terminal 2. What about this? Is it coming on? 1. Terminal 1. Yes, I can see it. Terminal 1. Terminal 1. So this sensor 2 is connected to terminal 1. This sensor 3 is connected to terminal 2. One terminal is on there. There's one input on. Input what? 0. Now look at it. When I move this man away, where is the input? It's gone. So that means this magnetic sensor is a normally closed sensor. When the piston moves away, it goes off. But when the piston comes back, it closes. So I demonstrate those 3 sensors now. Am I correct?
Yes, sir.
Now, I just demonstrate now that all these guys, that they are 24 volt, they are common, has been joined together, right? Yes, that they only waiting for what? Positive. Yeah, that this terminal all is positive. Am I correct?
Yes, sir.
So it means if I look for this man now, you see, SV2, SV, solenoid valve 2. Solenoid valve 2. If I come to this drawing now, I'm looking for SV2. I look at the letter. SV2, terminal what? 32. Where's 32 here?
32.
Correct. If I give this man 32 light, I've not seen. 32. 32.
Yes, sir.
Only one signal, because the 0 has been what? Joined together. SV1 from the leg end here. SV1 33, just beside 32. Can we see it?
Yes, sir.
31, 32. I hope you are following me.
Yes, sir.
Now, if I now, so that means almost all of them, see, almost all of them, they already have their connection, right? Electrically connected, pneumatically connected, mechanically assembled, and the sensor are bringing signal, and we're just ready for a program to download, and they will go into action. Are we making sense of this?
Yes, sir.
Now, this man is staying on his own. He's the source of inputs of the air. The air will come from the compressor. From the compressor. What do you call this?
Compressor.
The compressor will supply the pressurized air. And when you start using your air, and you discover the pressure is what? It's low. Then you start your machine. Are we making sense of that? Yes, I'm good. I love it now. So now from the input, now when you put this air, I put it firmly. Now I want to send the air to this. This guy is not the same as this guy, right?
Yes, sir.
It's also not the same as this guy. They have different mechanical strength. This guy will require more pressure to do his job compared to this guy. Because obviously, this is a very strong big cylinder. This is a very small one, cylinder. So, in design, we look at the maximum pressure required for the device. This guy is the one that requires the maximum pressure. For this thing to work very well, our pressure must be equal to what this man in there. If we only bring a small pressure to operate this man will not work. So will not work because it's not the same pressure. Now, if we now get to small devices like this is also a device, a pneumatic device. That the pressure, because we are bringing in big pressure because of who? Because of this guy. But that pressure might be too much for what? For the other guy. We now put a pressure reducer, regulator. You see this one? It's pressure regulator. So the pressure that is coming out from this actuator is to operate this guy. If it's too much, I can lock it to give it small pressure. That means I can bring in big pressure and reduce it to get small what? Small pressure. Small pressure. So if I stop this now, if I put on this here, now okay, I have small liquid here. We'll drop that. You see this man is under pressure now, Yes, sir. This guy is under pressure. Almost all of them. I can't even pull this one out again. Now they are waiting for signal. If I give this man his right signal, come out, Yes, sir. So what I say you should do, instead of me doing this, is your program, that should do it. You hear that sound, When you hear that sound, it means the system is working. But when you hear this kind of sound, continuous, there's a leakage. And leakage is very costly. So, now, as this man eats that, as this man moves forward, we expect this sensor V3, this man, sensor
SS2.
is terminal what there. If I come back here, it disappears, right? That disappears, okay? Okay? So, now,
The pressure is small.
very good. The pressure is low because I turn it off and there is leakage, So, which we need to resolve before you start your work. See that small gripper?
Yes, sir.
You can see the reed switch underneath also. And from here, what is the input of that signal? Input 3. I mean, that reed switch has been connected to the input of the PLC. Okay? So what else that hasn't worked here? Almost everything. PLC again. Now this one is there for training purpose. You see this one, it looks like start and stop button, right?
Yes, sir.
But it's a pneumatic switch button. If I should put pressure here, if I press here, the pressure will come up from here. So I can use this to control any of this. Instead of electric, I can do manual control. If I put here, if I press, come up from here. So whatever I connected it to, it operates it. So instead of this guy now going to this guy, I can bring this guy here, okay?
Yes, sir.
During complex training, we are going to be, this guy will talk to another thing that going to do, but just start from something basic, have the grip understanding. We are only going to program 2 cylinder now. When you do good on that, we'll move on to say, add this, when this one happens. It's just to get you to have insight, understanding of how complex program can be. Every complex program starts from what?
Somewhere.
From small program. And I told you how we remove those things yesterday. You can see the way I just remove it now.
Yes, sir.
If you are trying to remove it without pressing that, it can never be easy. You can see that if I did not press that, I will just destroy it. Did you understand?